All right, good morning, class. Today we're going to wrap up our unit that we've been working on with the last topic of aquifers. I know last week you did some reading about aquifers, and we did discuss them a little bit when we were doing the labs for porosity and permeability.
All right, we're going to continue on more with doing some labeling on our notes. So on your notes, you will see there's two diagrams. One's really a chart, and one is a chart, but we're going to make it into a diagram. And at the top of our diagram, it has the word atmosphere. And if you see up here, there's a cloud at the top of our diagram. So this is just representing the air above Earth's surface. Feel free to draw in the cloud if you would like. And then I have this dotted line that says Earth's surface. And you'll notice that on this diagram, there's a tree. Feel free to draw any grass or trees or anything to represent the Earth's surface. This will also tie into something else we're going to talk about soon. And then you'll notice that beneath the Earth's surface, but above this other dotted line, this is going to be where we label the zone of aeration. Okay, make sure you spell it right.
All right, so the zone of aeration we're going to talk more about in the notes coming up, but right now I just want you to label that area. Now notice in this yellow area on the diagram, it does have two other words labeled within it. One, you probably already are aware of. That word is infiltration. So kind of bring back in from your back of your brain what you have stored back there about that word. Infiltration means that water is able to enter the soil. And so there must be some pores or some open areas on the surface of Earth where water can seep down into the ground. Now this word over here, capillary, and I would like you to write both of these words in and draw the arrows along with them so that when we talk about them later, you can kind of go back to your diagram to draw back on the meanings of them. But capillary action is how water, it has to do with how water can move underground. And so we will be discussing that at the very end of the notes. All right, on the dotted line, the second one down, it's a different kind of dotted line. I want you to write on the line water table. Now this is the word that you read about last week, but you might not really have understood, and we're going to study it more today. So water table is what you need to write on that line. What I will tell you is that the blue color represented beneath the word water table is representing water. And above that, while there is some water, it's also a mixture of other things as well. So beneath the water table line, in all of the pores, open spaces beneath it, it is filled with water. Now, as we're talking about being filled with water, we're going to talk about the second zone that where all the pores are filled with water, and that's called the zone of saturation. Okay? And kind of makes sense if you think about it, because we've talked about how when the water vapor in the air, when the air cannot hold any more water vapor, it's saturated with water vapor. Well, when the ground can't hold any more water in its pores, when it's completely filled with water and soil particles, then that is saturated land. And so we call that the zone of saturation. So hopefully by now you have the two zones labeled, as well as the water table line. And you kind of understand that the water table line is simply a dividing point. It's an imaginary line that divides the ground that is saturated with water and the ground that's not so much as saturated with water. Which if you look right here, and you can write this down if you want on your notes, this would be the soil moisture storage. Well, you know what? This is also called an aquifer. So the zone of saturation, and we're going to repeat this later in our notes, but that is what an aquifer is. It is water-bearing or water-holding soil and rock. Now, if you notice, all of this land is on top of an area that's called impermeable bedrock. Now, if you think about your vocab words, the word permeable means that water can flow through it. But the word impermeable would mean the water cannot flow through it. And so this water is sitting on top of here. It doesn't have any pores to go down into the ground any further. And so as water collects, it just fills up the pores this way. Okay. Now, all of these areas of the ground, both the zone of aeration and the zone of saturation, are considered permeable, which means water can flow through it. The only impermeable area is the area at the bottom, which
is the impermeable bedrock. So what you might want to do on your notes is actually write beside bedrock impermeable. Another name for bedrock is just solid rock. So when you see something like this on a diagram, you would know that water cannot flow through it. So water would sit on top of it. All right, so now we're going to start filling in the chart beneath. I'm going to kind of give you some clues, the vocab terms. The description goes in the middle, and then you've got other important information. So as far as the zone of aeration, that is our first vocab term, you want to include some of this information. So it says aerate means to add air to something. So that's more of not like the description of the actual zone, but just other important information that might help you remember what the zone is about. So you might want to say that aerate means to add air. I bet some of your parents have their yards aerated, and that just means that they are digging out little areas of their yard to allow air exchange to go into the ground to allow for better grass to grow and plants to grow. Now, the actual description for zone of aeration is more right here. It's the upper layer of the ground above the water table. So again, it exists above that imaginary line, and it is also, you need to include, partially filled with air and partially filled with water. So the pores are not saturated with water, they both have some air and some water in it. Okay, so moving on, and please pause if you need to get the notes, but your second vocab term is water table. Water table, as you know, is the imaginary line that divides the zone of aeration, which again is up here, includes air and water in the pores, and the saturated zone, which means it's all water in the pores. So it divides those two areas up. So that is the description, really, is that it's an imaginary line that divides the two zones under the ground. And it marks the top of the water, like where the water, the aquifer is. So over here under important information, it marks the top of the aquifer. Something else that you can write as far as other important information is that it rises and falls due to how much groundwater. And sometimes we need to think about, like, well, what causes groundwater? And we talked about that last week, do you remember? Groundwater mainly comes from precipitation and it landing on an area where there are pores and the water can seep or infiltrate into the ground. So that is what causes the water table line then to rise. As that water seeps in, that water is going to go down until it reaches the zone of saturation. It's going to fill in any pores above it that aren't completely saturated, and that water table line just kind of lifts up. So the zone of aeration gets smaller, the zone of saturation gets bigger. All right, so back to the zone of saturation. This is our third vocab term. As far as the description, it will be the layer under the water table where the ground is saturated with water. And it's very important to know that another term for this is aquifer, the whole point of these notes. So zone of saturation is a synonym for aquifer. It usually has an area of impermeable rock beneath us. So other important information over here, impermeable rock is located below it usually. And the more precipitation, the thicker this layer gets. And by the way, aquifers is where we extract our water from. All right, last but not least, I told you I would talk about capillary a little bit more. As you know, water moves underground. It can either be stored, where there's bedrock kind of all around it, or it can flow. And two forces create flow, and one is gravity, which I'm sure you know a lot about by now. But that is a pull towards the Earth's center, so that is going to pull the water down into the ground. But also, there's something called capillary action. And this is the ability of liquid to flow pretty much against gravity in narrow spaces without much assistance from anything else. And the properties of cohesion and adhesion assist with this. So yes, water can move upward. This is how plants take in water from the ground. Also, so that tree that you drew on the top of your diagram, or those plants, that's where that capillary action is going up. It's being pulled from the roots. All right, tomorrow in class we'll do a quick capillary action demo. I'm sure you've seen some like this before.